BM25 can punish long documents too hard. BM25 Plus shows one simple scoring change that makes long document ranking fairer. You'll see how to connect the pieces into a workflow that contrasts baseline rankings and rebalances scores toward richer documents. I'm Professor Pi, teaching Search and IR with simple Python. Search engineers reach for BM25 when they want simple, fast, and interpretable relevance. BM25 balances term frequency with document length, so short focus notes do not always outrank everything. But that same length normalization can bury long, information-dense documents that match many query terms. In product settings, this looks like a long handbook, losing to a 2-paragraph cheat sheet, even when the handbook answers more sub-questions. The intuitive idea of BM25 Plus, or BM25 Plus, is small and practical. You keep BM25 saturation math, but you add a small constant boost for each matching term. That lift prevents long documents from being overly penalized simply because they are long. Strengths are fairness to rich documents and minimal added complexity. The trade-off is tuning one extra parameter, so the boost does not overwhelm concise winners. We will build a tiny reproducible example that shows the distortion, computes BM25, then applies BM25 Plus and compares ranks. You will see how the scores shift and why a modest delta can be a useful lever. Quick note: this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Let us start by creating the toy corpus and measuring how document length skews scores. This snippet sets up a toy corpus and measures how document length skews our starting point. You'll see we call tokenize and store the results in docs, so the exact token lists are available later. DocLens then records each document's token count and we compute average len. The practical takeaway is visible. The long guide hits 24 tokens, while most notes sit under 8, which pushes average len to about 10.2, and makes it clear why BM25's length normalization can suppress comprehensive documents before we even score term matches. Seeing lengths equals 6, 7, 7, 7, 24 makes that imbalance obvious. Now we need to see how BM25 does length normalization in practice, and why it can shrink term effects for long documents. This example captures BM25's saturation term to reveal its built-in length penalty. Here we compute K1 and B, and then build doc sets for deduplicated terms, so IDF is straightforward. For each document, we calculate norm, using norm equals frec plus K1, 1 minus B, plus B times len doc, or average len, which shows how the same raw term frequency becomes a smaller effective contribution in the long handbook. In our run, the compact tutorial gets about a 1.16 boost, while the handbook only sees roughly 0.62, and the TF-SAT evaluation output makes that contrast easy to point at. We saw the raw saturation numbers. Next, we assemble the full BM25 score across multiple query terms to watch the ranked list. This code assembles full BM25 scores, so you can watch the bias play out across the ranked list. We wrap up, counter, pre-computed doc sets, and a shared query terms list to compute IDF once and reuse it. The BM25 score logic keeps the same norm formula K1 times 1 minus B plus B times len doc over average len, so each term is weighted under the same saturation curve before we sum across terms. When you print BM25 scores, the long document trails the shorter one, about 0.63 versus 0.78, which makes the case that BM25's length normalization push down deep but relevant texts. So far, BM25 favors compact documents. We can add a per-term constant to give back some probability mass to long-term rich docs. This snippet introduces BM25 Plus to add a constant lift back into each matching term. In BM25 Plus score, we reuse the normalization from earlier, but add delta to the term contribution after the BM25 numerator step, so each match gets a small fixed boost. The tuning point is delta. Set it too high and lengthy docs dominate. Set it modest and documents with many hits regain ground without overwhelming concise winners. In our example, the handbook, which matches 3 query terms, picks up an extra raw boost, 3 times delta. And the printed BM25 Plus scores show it edging ahead of the tutorial. With both score lists computed, comparing orders makes the effect clear and actionable for product work. This example compares the ranking orders to make the BM25 Plus effect tangible. We compute BM25 order and BM25 Plus order using Python's stable sort, so rank changes reflect just the score differences. Then we quantify lift and report long doc rank change from 2 to 1, which is the simple shareable result. Adding BM25 Plus move the handbook from second to first. The numeric lift, about 0.50 in this run, is the kind of number you can cite in a model card or tuning note. This toy example maps easily to a real project. Replace the 5 documents with a subset of your product corpus. Compute document lengths and IDF across the same index, and add BM25 Plus as a calibrated re-ranking step for queries that benefit from deeper documents. The same delta can be tuned on a small validation set to balance precision and recall. Recap: BM25 Plus is BM25 with a small per-term delta added to prevent long, information-rich documents from being unfairly penalized. Use it when your corpus contains long, authoritative pieces that match many query facets but are dropping in rank. One caveat is that delta needs tuning, so you do not simply promote verbosity over relevance. Next step: tune the delta against held-out queries and measure rank metrics, so you find the smallest lift that recovers useful long documents without hurting precision. If short, practical IR helps, subscribe and watch the IR videos.